Hello everyone. Welcome to the second sponsors workshop for the Kaya Wave Stablecoin Summer Hackathon. My name is Sean. I think most of you are familiar with me because I've been host of the Dune workshop as well as the Certik workshop, and I think we have another workshop tomorrow as well. So yeah. So enough about me. You're all here for Certik, I think. So with me, I have Minzhi from Certik. He is the audit partner at Certik, and today he will be going through DeFi security workshop, audit prep, and common exploits and automation in action. So just some quick housekeeping from me. We will have a short Q&A session at the end of the workshop. Minju will be here. He will be answering all your questions that, if you have any, please put them in the comments below. And yeah, without further ado, I'll hand it off to Minju, and then we'll just kick it up from there. Okay, cool. So yeah, Minju, please take it away. I will.
Okay. Yeah. Can you see my screen?
Yes. Cool.
Okay. So hello everyone. My name is Minju. I'm the audit partner from Certik. Pretty excited to give the presentation today here. So I'm going to talk about So today I'm going to talk about several topics. First of all, I will give an audit process overview, basically what we do during an audit. And then I will talk about how to prepare for an audit from the project's perspective. Next, I will talk about some common DeFi exploits that we have encountered during the audit, as well as some previous instances. Last but not least, I will do a little demo for one of our automation tool called Certik Skyflow. So without further ado, let's get started. So the first step of an audit for us is to do an architecture review. After review, we will review the project white paper and technical documentation that outlining the detailed architecture of the project. After architecture extraction involves examining the interaction between components, the handling of external inputs, the import of libraries, the implementation of novel ideas, the compliance with the code standards, etc. Basically, we are trying to gain a brief picture about what the code base is doing and some certain features about the code. Sometimes we will notice that the code is either poorly organized or very unconventional. In this case, the auditors may need to manually determine the component structure and relationships through the function by function and source file analysis. It is also important to determine if a project is an original design or a fork of another project. We have a different strategy for that. After we finish the architecture review, we will do a threat modeling for each project. A threat modeling is a representation of a system that includes a description of its critical assets, resources, and security requirements, as well as a list of its potential vulnerabilities and possible security threats. For example, in a governance system, we will ask the following questions. Who can create the proposals? What are the requirements for a user to creating a proposal? What percentage of votes or the threshold is required for a proposal to pass? How long is the validation period for a proposal to be executed? What voting token is being used and what voting mechanism does the project utilize? What configurations can be modified by privilege roles? So the outcome of the threat modeling will produce a security checklist that will get the security audit process and ensures a thorough evaluation of the system and the security posture. Next, we will do a static analysis and formal verification if applicable. So we have a database of over 90,000 previous findings from more than around 5,000 audits and incidents. We will have tools to run through the code based on the previous knowledge base. So the tool will test the code statically and are capable of identifying some common issues like insecure code patterns and generating diagrams to provide insights into the smart contracts. So there are some common findings from the tools, including logical issues, reentrancy risks, lack of access controls, overflow, underflow, and some guess optimizations. If applicable, we will also utilize formal verification to test the code. Formal verification is a mathematical method of proving that a program functions as intended. It involves expressing the program's properties and the expected behavior as mathematical formulas and then using automated tools to check if these formulas are true. All of the findings generated by tools will be sent to the auditors and are subject to manual verification by auditors to eliminate false positives and enhance the clarity of results before putting into the report. Next, the most crucial part of an audit is the manual review. The manual review involves a meticulous line-by-line examination of the code and can be divided into two parts, micro-auditing and macro-auditing. Micro-auditing involves analyzing each input parameter, variable, and function, and reviewing function access and state variable modifications, as well as compare similar functions. Macro-auditing involves identifying global vulnerabilities by understanding the project's call and contract hierarchy, checking different if-else conditions, and reviewing interactions among multiple functions located in different parts of the code base. So the manual review requires both a hackers and developers mindset. The hacker's mindset will be utilized to uncover any potential vulnerabilities that may be exploited. The developer's mindset will be used to verify implementation and identify efficiency in the code, such as efficient gas usage and lack of code modularity. So for most projects, we'll assign multiple auditors to collaborate to complete the manual review process. After the manual review is finished, we'll begin to write the audit reports. So the audit reports will start with an overview of the project's type, ecosystem, and scope, and then explain our methodology, followed by auditor's notes and specific findings. Each finding will include some basic information such as the category, severity, finding elevation, and stuff. And we will provide our insight in the 4 distinct written sections. The descriptive section defines the findings context and reviews security implications. The scenario section walks through the steps of a potential exploit. The proof of concept section includes the exploit script and the expected output. The recommendation section describes some actionable mitigation steps for the project to fix the issue. After we wrap up the report and deliver to the client, we will move the audit will move to the remediation phase. The remediation phase involves the ongoing dialogue between the client and the auditors that aim to resolve the findings and further improve the security of a project. The findings are updated to reflect any changes made to the code and are published in the updated report. Okay, so this is what we do during audit. So now I will talk about from a project's perspective, how to prepare for an audit to maximize the outcome. So the first step is to outlining the scope of the audit and goals. So the project team can ask themselves, what needs to be audited, or what do we like to be audited? Is it the full set of the files, or only the essential and unique functions? Which modules are most important to the system? Are there any particular attack scenario you would like us to pay more attention to? Also, also the timeline and the budget will also affect the scope of the audit. After we receive all of those informations, we will prepare a proposal that best meets the project's needs and ensure the proper allocation of the resources. It is also important to have, we also recommend to have a comprehensive documentation before the code is delivered to the auditors. Documentation should be clear, comprehensive, and clearly explain how the system works. Good documentation can help auditors understand the intended design, reduce the guesswork, and only focus on the security aspect of the code base. So there are 3 aspects regarding the documentation. The first is the README file. It's basically it's a text file. It can be a text file containing essential information, including project description, as well as instructions to build projects and run tests. Next is the technical document. It should be an overview of the system, the problems the project aims to solve, the intended functionalities of the various components of the system. Last but not least is the inline code comments. Comprehensive and accurate code comments will assist auditors in understanding the intentions of the code, as well as highlighting any potential limitations it may contain. During the development, it's also critical to measure the code quality. With a high quality code base, our auditors can focus more on the code itself rather than being preoccupied with attempting to uncover meanings of a particular code snippet. There are several recommendations we have. So first of all is to ensure the style consistency across the code base. And we recommend to use linters to help analyze the source code and flag programming errors, bugs, and stylistic errors. Next is to dispose the redundant or duplicate code. We understand that during the development process, some code may be not being used, no longer being used because business requirements or just some changes to the code base. And we recommend to remove the redundant code. Disposal of the redundant code and comments will prevent auditors from wasting time on irrelevant details. Last is to use the up-to-date dependencies. So the battle test libraries can and should be utilized, and also ensure those dependency and libraries are up to date. For example, if you are using the OpenZeppelin library, it is recommend to use we always recommend to use the latest version of the OpenZeppelin library, because previous versions of the library may contain vulnerabilities. For example, prior to OpenZeppelin, I believe is 4.7 or 4.8. There is a known vulnerability called signature malleability in the EC recover function. So if you are using a previous version of the OpenZeppelin library, your code might be vulnerable. But if you are using the latest version, you should be fine. And next is the test is also an important aspect for the code base. Ensure the code that compiles and executes without error and behaves as expected. It's critical to know that audit does not replace the test and vice versa. We recommend creating unit tests to cover all functionalities of the system. The test should consider edge cases and error handling. And we also recommend creating tests which target multiple components under different use cases. It is also a good idea to test smart contracts on a test net before deploying to the mainnet. And before the audit starts, our auditors will confirm with the project team to specify the community hash for the smart contract audits. And please try to avoid changing the commit once the audit starts. In case of penetration testing, we recommend deploy a stable environment. A stable testing environment will enable an efficient pen test, whereas an unstable environment with server issues can vastly hinder the timeline and overall process. We'll dive into more aspect for the pen test in the next workshop from one of my colleagues. Okay, so now let's talk about some common exploits we see during the audit and some of the previous incidents. So the first topic I would like to talk about is access control. Access control is a pretty basic yet important concept for both Web 2 and Web 3 security. From the contract perspective, access control can prevent unauthorized actions like token minting, pausing, or upgrading. It basically prevents users from actions that they are not supposed to. So let's take a look at this code snippet. This is one of the code we received during an audit. So the project team is trying to implement the blacklist functionality using the access control OpenZeppelin library. They implement the add to blacklist and remove from blacklist functions. And the issue here is the access control library is not intended for the role management like the blacklist. It's more like reserved for the privilege role management. So it includes a function called renounce role, which will allow the role to just renounce their role. So if the project team is using the library for the functionality like blacklist, the address being blacklist can simply call the renounce role function to get them off the blacklist, making the blacklist completely ineffective. So to implement the blacklist, the best way is still to maintain a mapping and use the Boolean value to indicate whether the address is being blacklisted or not. So whenever the code you are trying to write, it is very important to understand the dependency you are trying to use, if it is applicable in the use case, and does it contain any vulnerabilities. With regard to how to prevent access control related issues, we also recommend applying modifiers to every privilege function, review the constructor and the initializer to make sure that the credit role is assigned during deployment, and also avoid hard code privilege address without an aggregate path, so that in case of a private key compromise for the privilege address, there is still ways to recover. If possible, we always recommend to use time locks and multisig for high-risk actions to allow monitoring. Last but not least, we recommend when you are writing tests, it's important to test with scenarios where an attacker attempts privilege escalation. Okay, so now let's talk about the flash loan. So flash loans are a type of uncollateralized loan in the DeFi ecosystem, where assets are borrowed and returned within the same blockchain transaction. There are three common use cases for the flash loan: arbitrage, liquidation, and collateral swap. So here is an example of a simple flash loan arbitrage. So a user noticed that the same asset has a different price on DEX A and DEX B, where the DEX A has a lower price. So what he can do is he can flash loan some ETH from another place and buy the asset from DEX A and sell the asset with a higher price on DEX B. And during which he will receive more ETH than he spends. After he pays back the flash loan, the remaining ETH will be his profit. So historically, a lot of exploits have utilized the flash loan because it's really hard to have a lot of tokens to perform the attack in most cases. So I want to talk about one of the vulnerabilities that happens in some famous projects. In Compound Finance and V2, there is a known vulnerability called precision loss. From a high level, you can consider that if one of the lending pool is empty, an attacker can deposit a very small amount of token into the pool to mess up with the way they calculating the collateral value, allow the attacker to borrow more assets than he's supposed to. This issue was first being exploited in April in the 100 Finance incident, and after that there are multiple similar attacks happens. And today we will take a deeper look into one of the incidents, the Certik Finance incident. And the Certik Finance is a RV fork. So in RV, when a user provides collateral, the RV will mint some A tokens to the user, and when the user redeems his collateral, the A token will be burned. So the amount of A token being mint and burned is calculated in the mint and burn function shown in the code snippet. As you can see, there is basically it's related to the index. If the index is larger, the larger the index, the less token they will receive. So the index is the variable index is called the reserve.liquidity.index. So the value is calculated in the function cumulative to liquidity index in the code snippet. As you can see in the first line, it will be divided by the total liquidity. So you can get the general idea that if the total liquidity is very small, the amount to liquidity ratio will be very big, and the result will be very big. So this function will be triggered whenever a flash loan function is called. So RV provides the flash loan functionality. When the flash loan happens, the protocol will charge a certain percentage of the fee, and the collected fee will be distributed to all the collateral provider. So this is achieved by updating the variable liquidity index using the function cumulative to liquidity index in the following code snippet. So what the attacker can do here is the attacker first will deposit, when the attacker notices the USDC pool is empty, he can deposit 1 WEI, the minimum amount of the USDC into the pool to get 1 LUSDC. Then the attacker will transfer 15,000 USDC to the LUSDC contract directly. This is preparing, can be considered as a preparation step for the following exploit. Then the attacker will repeatedly call flash loan to borrow those USDC from the contract. Since, as mentioned previously, when the flash loan function is called, the index will be updated, and at this moment, the total liquidity is only one way, so the index will be severely inflated after all those flash loans. And attacker will use another, then after this, the attacker will use another address to deposit USDC to the contract. Due to the inflated index, he will only get 1 LUSDC this time. But then he is able to withdraw more USDC than he deposited because the index is pretty large. So both when he withdraws 2,000 USDC, he only needs to burn 1 USDC. And because the solidity, when handling division, solidity always run down. You can consider that you can consider the case where one divided 1 is 1, but 1.9 divided 1 is also 1 in solidity. And the attacker repeats this two steps multiple times. Basically, what he's trying to do here is to get all the 15,000 USDC back to himself. After all this happens, the attacker will have a pool with only 1 way USDC as a deposit and with a very large index, which the index is also used to calculate the value of the collateral. So at this point, the attacker is able to borrow all the assets from other pools, effectively draining the contract. So this vulnerability is widely known by Avi and Compound and other projects as well. But the issue is not fixed from the code level because it's kind of hard to fix this issue from the code level, as this is what Solidity is supposed to do, is to run down. And furthermore, there is a very easy way to prevent this issue from happening from an operation perspective. As long as whenever a project team creates the pool, as long as the pool is not empty, the exploit is not applicable. So you can just deposit a few tokens into the pool whenever you try to open a new one. If possible, to prevent flash loan attack, it's also a good idea to break sensitive operation into multiple transactions. For example, in a lending protocol, if possible, you could limit the deposit and borrow into 2 different transactions instead of 1. Introduce a time delay or block-based cooldowns between each key steps. Sometimes, in some cases, the flash loan attack also involves the price manipulation. So we recommend to avoid relying the price on a single DEX pair. It is recommended to use oracles or a TWAP to calculate the price for a certain asset. Next, I want to talk about the proxy. So the proxy is a design pattern that allows a contract's logic to be upgraded without changing its address. As many of you guys know, once the contract is deployed to the blockchain, you cannot change the code in the contract. But in the real world scenarios, there are many cases where you want to change the code. For example, there is a business requirements, or you want to fix some of the vulnerability inside the code. So the proxy provides a way to do that. What the proxy does is that it separates the storage from the logic. So whenever you want to do an upgrade, you can just change the implement. You can deploy a new logic contract and point the proxy to the new logic contract, but you are still using the same storage. So this effectively updates the contract. It is essential for protocol flexibility. A lot of famous protocols are using a proxy. For example, USDC is using a proxy. But proxy will also introduce unique risks. Some common proxy patterns include UUPS, transparent, and bacon. Bacon proxy. The first two is pretty straightforward, where the bacon will be used when you have multiple proxies and you want to use the same contract for the implementation. So one of the most common issues we encountered during audit regarding proxy is the storage collision. And as you can, so the following two code snippets are the storage layout in a contract before and after the upgrade. As you can see, the contract, the project adds a mapping after the upgrade and reduce the gap from 50 to 48. The issue here is that the mapping occupies 32 bytes, which is the same as using 256. The upgrade will add one mapping but reduce the gap by 2, which will cause the entire story layout shorter, reduce the entire story layout by 1. So what will happen here is that if a contract inherits the previous contract, the first variable defined in the parent contract will shift left 1 spot. So, and it will point to the last byte of the gap, which is always to be 0. So in this case, the variable a will equal 0 after the upgrade, no matter what the value is before the upgrade. So for the proxy, please only use the proxy pattern when necessary. If you don't anticipate that you want to do an upgrade for the proxy, you don't need to do an upgrade for your contract. There is no point using the proxy. And do not implement the proxy, do not write the proxy from scratch. There are multiple very mature libraries that can be used. For example, OpenZeppelin provides the proxy for both UUPS and transparent. And when using the libraries, avoid modifying the library to introduce unnecessary risks. Next is when you are trying to declare the variable value, you cannot do that when you are using proxy. You cannot do that during the construction or declaration, because when you do that in the constructor, the variable will only be stored in the storage of the implementation contract instead of the proxy contract. So what you need to do is you need to have initialize function to assign those values and call the initialize function from the proxy contract. And but you also need to make sure that the initialize function in the logic contract cannot be called or has already been called to avoid unnecessary issues. And in case of inherit, because sometimes you want to inherit some libraries, for example, Possible and stuff, upgradable contracts should only inherit from other upgradable contracts. So OpenZeppelin basically provides two sets of those libraries. One is for upgradable, the other one is for the regular. You'll always want to use the upgradable ones because it will not have any storage collision issues if you are using those. And whenever you are doing an upgrade, always check for storage collision, and you can write tests for those. And last is for the implementation contract, avoid using self-destruct. Self-destruct is an opcode which will remove the contract from the chain. This if the implementation contract is self-destruct, the proxy will be unavailable. So if possible, do not use self-destruct here. And also be very careful about performing delegate call and call to untrusted contracts in the implementation. Actually, we have a blog talking more about the proxy contract security. You can check it out after the presentation. Next, I want to talk about oracles. So Oracle can be seen as a middleware that provides off-chain data to smart contracts. It enables DeFi protocol to access real-world information such as price, interest rates, and events. The common types of oracle include centralized oracles, decentralized oracles, and on-chain oracles. So these are some of the common oracle vulnerabilities we see during the audit. Sometimes the oracle may use, sometimes when the asset is pretty rare, the Oracle may use a low liquidity pool for the price feed for a certain asset. In this case, if a user has enough tokens, it is possible to perform the price manipulation via low liquidity pools to make the Oracle feed a wrong price. Next is the stale price feeds. So the Oracle may be, due to some technical issues from the Oracle side, the Oracle may return outdated data due to low update frequency. In the contract using the Oracle, it is important to check if the price is up to date. Next is the rounding or aggregation errors. So as many of you guys know, the different tokens have different decimals, and different oracles have a different way to handle those decimals. Basically, it will return the data in a different format. So it is important to understand the oracle you are used and what the format of the return value is, so that you can convert it to the correct decimal and the correct format you are trying to use. Next is the data source corruption. Basically, the off-chain APIs or data providers of the Oracle is being exploited. Okay, the following code snippet is a project one of our clients is trying to integrate the piece price feed. As you can see, they check the price age basically, and to make sure that the price is up to date. And if the price is up to date, it will return the price and the published time of the price. Otherwise, it will return 0. So the piece price feed, in addition to the timestamp and the price, it will also publish a confidence interval. So the reasoning behind that is there is no one single price for a product. The confidence interval can be seen as a range of the price. So if the confidence interval is large, you can see it can see that the price is fluctuating a lot. So this is very useful in high volatility periods. But if the interval is too big, the price is not as reliable. So in this case, there are two options. First is to use a discounted price in the direction favorable of the project, or a more straightforward way is to pause new activities that depends on the price of the asset. So we spot this issue during the audit and report to the client, and this is how the client fixed the issue. So the client adds a highlight code snippet to handle the interval. So if the interval is, so they have a config interval confidence ratio called the config.max confidence ratio. If the confidence interval return from the piece price feed is larger than the config value, it will not use the price. It will fall back to the Chainlink oracle. If the confidence ratio is smaller than the config threshold, the price will be used. It is important to read the document of the oracle being integrated to understand what the return value each of the return value is, and make sure that it is properly validated, and to make sure that the value is up to date and the value is accurate. It's also a good idea to monitor the oracle health in real time to make sure that the oracle is operating normally. If possible, we also recommend to use multiple oracle sources, so that if one of the oracle is not working, you can still fall back to the other one. This can be used to avoid single point of failure. When you are writing tests, it's also important to simulate edge cases related to the oracle failure to make sure that the project behaves as intended when the oracle does not work. Okay, so let's move to the last part of the presentation. I will do a little demo about our in-house tools called Certik Skyflow. This below is a high-level workflow of our tools. So the project loader will load the source code base to the planner. The planner can be seen as a preprocessor that extracts necessary information. The information will include the key functions that is the key functions from the code base, the context of those functions, and it will try to fetch the checklist and relevant findings from our database. All those information will be sent to the scanner. The scanner will basically scan the code and generates raw results for the findings. All of the raw results will be sent to the finding validator, which will verify the finding from scanners and remove some false positives. After this, the result will be sent to the finding enhancer, which will add additional information such as severity and recommendation and proof of concept to an existing finding. All those information will be generated as a report and output it to the auditors for review. And the auditor will do some fine-tuning to the results and refine the distribution or recommendation and put them into the report. Okay, so let's start by running the tools, because it will take a few minutes for the tool to generate results, and then after the tool started, I will give a brief introduction about the code base and what the vulnerability is about. Okay, so let's go back. Okay, so the code is being scanned. It's called the Paxos. It's one of the stablecoin contract from the Paxos called USDL. USDL provides a yield through a rebasing mechanism. So basically, over time, the token holders will see their balance increase as a result of the rebasing. This is a public contract available on GitHub, and it was audited by us. So the contract provides the ability to set the rebase multiplier ahead of time through use of 3 contract variables: before increase multiplier, after increase multiplier, and multiplier increase time. The multiplier increase time is a timestamp that dictates which multiplier is active when compared against the current timestamp. For example, if multiplier increase time is greater than the block timestamp, before increase multiplier will be active. Likewise, if the multiplier increase time is less or equal to the block timestamp, after increase multiplier is active, the contract will provide a getter to return the active multiplier. During the audit, we found an issue here is when the rebase row is trying to increase the rebase multiplier, and when the rebase rate equals 0, the wrong value is assigned to the before increase multiplier. Since the rebase, the highlight part should be after increase multiplier instead of the before increase multiplier, because the rebase multiplier should only be increasing or being equal to the previous one. The rebase multiplier should never decrease. So let's see if the tool can generate this finding. Perfect timing. It's been finished. So the code is right here. As you can see, the issue is in this line. Let's see if the code can generate this finding. Okay, so let's take let's take a look at all the findings being generated. There are 3 findings being generated, and the first, let's take a look at each one. The first one is past day scheduling lets the compound rebase up arbitrarily many times in one go. So this finding is talk about the multiplier increase time. However, this multiplier is set by the rebase row. So since it's set by rebase row, we should always assume that the rebase row is not malicious, it's not being compromised. Otherwise, there will be more issues to be concerned about. Next is this issue is talk about the expected supply right here is will be the expected supply here will be if there is a wrong value being passed, there will be some potential issues. But the thing here is this function is also controlled by rebase row, as you can see here, so that the issue will not, so that as mentioned before, we should always assume the correct value is passed because it's controlled by a previous row. So this should not be a very important issue or not even an issue. Okay, so let's look at the third one. So the title says the compounding from the wrong base, the after increase instead of before over applies increase when a past increase has been finalized. So this issue is still talking about here. It's talking about when the rebase rate is larger than 0, the new after is computed from the current after, not from before. So if modifier is already in the past, the state still has before it's smaller than after. So the issue, as you can see, that the issue here talks about is still about the. So this is the right location about the issue, but the root cause is also correct. It should be using the after increase instead of the before. But as you can see, the impact is kind of messy here. This is the limitation of the tools, and especially it talks about let's say there are some potential issues if the function is being called like repeatedly or arbitrarily. However, that should not be the case. This is because the AI tool, as you can see in all of the three findings, it fails to understand that only the rebase row, this is a pre function, it is not called arbitrarily. So but this is something we are trying to improve. But as you can see, the root cause is successfully found, and auditors of those results will be sent to the auditors, and when the auditors can read these findings and make some refinements and before putting into the report. Okay, I believe that's all I have for today. So thank you guys for listening. Let's move to the AMA section.
Hello, everyone. I am back. So we do have right now we don't have any like hard questions in the chat, but maybe we can give it like a bit of time because I think so one thing, if you're not aware, is the stream is ever so slightly delayed a little bit. So it will just come and go as it is. So it might take a bit of time for people to like finish the stream and ask the questions.
Okay.
So maybe you can just hang out here for a little bit. And then, yeah. So hope everyone is doing fine today. I see the comment section is pretty active today. Still on about coffee and the intern going on about really random stuff. But yeah. Maybe we can just hold on for a little bit longer. Can you just here? I didn't actually expect. Yeah, I mean it's about right actually, about 45 minutes of talking, and then we have a short Q&A at this point. So yeah, hopefully it's okay. Any questions? We are taking. Oh, we do have a general question in the chat right now. I'll just show it right here. Yeah, we can do this because we're doing this. It's from Fermento. Sorry, just a general question. For hackathon projects, what is the minimum level of security developers should ensure before deploying?
Yeah. So the minimum you should do is to make sure at least based on, depending on the type of the product, right? If you are just like say you are just based on a project on a very well-known project and there is no vulnerability, you can do a deep audit, which will take will be substantially cheaper and shorter than a full scope audit. But if you are writing the code from scratch and it's pretty complicated, it's always recommended to do a full scope security review before deploying your contract to the mainnet, to the live mainnet. Yeah.
Okay, hopefully that answers your question. Maybe we're gonna give it just. Do we have any more questions? Hopefully it answers your question. Do you have any follow-up question? Oh, thanks for answering my question. Okay, cool. So yeah, I think we have time for maybe 2 more questions. So if anyone in chat wants to ask a question, that'd be great. I think maybe someone's typing up a really long question. That's why it's taking a bit of time, hopefully. We never know, right? So yeah, we're gonna give it maybe like 2-3 more minutes to see if anybody has any questions. General questions are fine as well. Certik is a major sponsor for this hackathon as well. So yeah, maybe gonna give it a few more time. Maybe I'll play some music while we wait, so it's not so quiet. Oh, it seems that someone is typing it out. Just gotta give it maybe a little bit of time for them to type it out. Yeah, someone commented saying, "Hey, hang on, I'm typing it out." Okay, cool. I'll just give it a bit of time. Yeah. Oh, we actually have about 2 questions. That's
Okay.
when we stop the music for a second. So we have. I mean, I'm seeing on the chat we have 2 questions, but on the actual thing we have 1. So let's share the first question first. What re-entrancy access control pitfalls do you see with upgradable proxies or ERC 4626 volts? Guidance on CEI versus re-entrancy guards across cross-functional calls and external callbacks and hooks.
Sorry, can you repeat that? I only get part of those.
Okay, so Asux here has asked, what re-entrancy/access control pitfalls do you still see with upgradable proxies or ERC 4626 volts? I mean, that's part 1 of the question.
Okay.
Yeah.
So yeah, I think the reentrancy is reentrancy and access control is like a very spread issue, but reentrancy has been largely prevented by the usage of the reentrancy guard, which is provided by OpenZeppelin. However, for the so the reentrancy guard is able to protect the cross-function reentrancy, but there might be cases for cross-contract reentrancy that is cross contract, so-called reentrancy, but that cross contract sometimes if the call happens cross contract, the reentrancy guard is not as effective here. And as for the ERC
4626.
Yeah, 4626. This I believe there is an implementation from the OpenZeppelin bot, and from the OpenZeppelin, which basically will provides like it basically will provides like a base implementation, I will say, and you guys can make some updates or upgrades to add some customized features to that. As I will say, it largely depends on what you are trying to add in addition to that, to depend on what kind of attack vectors it may contain and how to prevent that.
Okay, cool. I think they had another follow-up question. I'm sorry. There is another comment, but it's not showing up in the
No worries.
StreamYard thing. So I'm just going to show the second part. Any special handling when using multi-call batch patterns that can re-enter?
Yeah. So the multi-call is basically used for you can make basically allows you to make multiple calls in one transaction, in one function calls. So so for reentrancy, as long as you have the reentrant non-reentrant modifier, you should be fine. There's the more concerning issue regarding multi-call in my previous experience is that if you are trying to use native coins in the multi-call, there might be an issue because, as you know, the message value will be only passed as the message value, the native token. But multi-calls will treat each call have the same message value, but in reality, you only have the one message value being passed. So this part needs to be properly handled when you're using the multi-call.
Okay, I think they responded. Thanks for answering my questions. Hope they weren't too challenging. Okay, cool. We do have like one last question. I think we do have a bit of time because we do have one last question. I can't actually display it on the StreamYard thing, unfortunately, because I think there's a slight glitch in the StreamYard thing when you send it at the same time. So I think what I'll do is that I will just let me see if I can create a banner here really quickly because I can actually see the stream. Where is it? Here we go. See if I can just really quickly. At Chain Milo Melo, hopefully I'm pronouncing it right. I have a general question too. Just curious, what common security mistakes do devs usually make?
It's pretty hard to say. I will say the most common one we see is the misuse of the dependencies. So basically, they are using the library. They are incredibly using the dependency, like they are mistakenly integrating certain oracles or certain libraries. I think that's the most common one we see.
I see. Okay, hopefully that answers the question at Chain Melo. I'm sorry that I couldn't get your banner to comment to show up as like a normal banner, but hopefully it's fine. But yeah, if I'll probably maybe give it like one more minute to see if anyone else is typing a question. Otherwise, yeah, I think that's all the time we have for today. I'd like to thank firstly Minzhi for for like giving us the wonderful workshop and showing us the actual demo of it actually working in function. I think that was pretty cool. Yeah. So I'd like to thank him for coming and just showcasing to you all. Thank you all in the comments for participating in the Q&A and just asking questions. I think asking questions is something, especially for all the projects that are working and doing the actual making an actual dApp, mini dApp. I think it's super useful to attend these workshops and to ask the actual questions. Yeah. So I'm gonna leave it here. Minzhi, do you have any final words for the hackathon participants?
Actually, please make sure that you guys have your code tested and audited before before your project went live.
Yes, I think that's something that like a lot of projects that I see, especially coming from the schools, They do like, because we are working with a bunch of university and high school students here in Singapore, and then they're like, oh, this is the budget, and this is the breakdown of the budget, and then the first question, like obviously because we've been in the space for all these students, right? Like, where's the budget for auditing your contract? Because it's a big thing, right? Obviously these are students, they're not so aware. Yeah. So it's really funny how they some students are pretty good, or oh, we have an audit budget. Others are like, first question before you proceed on to anything further, where is your thing? Yeah. So I think they're learning, so it's not so good. It's pretty good, I think. But yeah. So yeah, thank you all for attending the session. And yeah, be sure we do have another session actually tomorrow with Avail, previously known as Arcana. We will have a tweet going live shortly in about 4 minutes time regarding the Avail / Arcana situation on our main X account. So to end it off, I think we can just follow at Bill and Kaya at Kaya Chain on X, as well as at Certik on X as well. They are obviously the ones where Minju works at. Yeah. So if there's nothing else, I think we can just end it here. Thank you all for attending, and yeah, I'll see you all tomorrow at the same time, at the same bad time, at obviously the same channels. Yeah. So okay, take care, everyone. Bye.
Bye.